All right, hello everybody, welcome back. Today we're going to do skill 25, graphing exponential functions. Exponential functions can be written as f of x equals a times b to the x minus h plus k. That's a lot of variables, so let's talk about what each one of them represent and how they're going to help us make our graph. So if a is positive, so if the number in front of the parentheses here is positive, the graph will be above k. If a is negative, then the graph will be below k. We can have an idea of how the graph will behave going from left to right by looking at b. If b is greater than 1, it will be a growth function, meaning the numbers will get bigger and bigger and bigger. A growth function will go to positive or negative infinity. It's either going to go up or down to infinity. If b is between 0 and 1, so it's a fraction that's between 0 and 1, like 1/2 or 2/3 or 3/4, it will be a decay function, meaning the numbers get smaller and smaller and smaller. A decay function will get closer and closer to, but never cross k. Our graph will always be above or below k. It will never cross k. K has a fancy name. K is the last number on the end. K is known as a horizontal asymptote. Asymptotes are lines that don't get crossed in a graph, and it goes horizontal, meaning across the graph. The graph will get close to, but never cross this line. So there we go again. The graph will always be above or below k. It will never cross k. And any term with a 0 as an exponent will equal 1. That means like 8 to the 0 power equals 1. 2 to the 0 power equals 1. 1/2 to the 0 power equals 1. All right, so let's see if we can use all of that information to make a graph. So let's look at our equation. Y equals, remember y equals is the same as x equals. F of x equals. So y equals 2 to the x plus 1 plus 1. So a is 1, b is 2. Let's talk about h and k. A horizontal asymptote is y equals 1, or k equals 1. So we need to draw this on our graph so we can get started. So k equals 1 is going to be right here. All right, so our graph is never going to cross that line. Is our graph going to be above or below the line? Let's see. So k is plus 1. A, the number in the front here is 1, the positive 1. So our graph should always be above the line that we just drew. When deciding which x values to use, in our function, we will almost always choose numbers that are near h. And in this case, h is up here. It's supposed to be a minus. It's supposed to be x minus h, but this is a plus. So that means in this case, h equals 1. All right, so we're going to start with 1, and we're going to fill in some of this work, and we're going to see if we can have an idea what this graph does. So we're going to make x equal 1. So then we have 2 parentheses. Oh wait, h is negative 1. Sorry, it's supposed to be minus. It turned into a plus, so now h is negative 1. All right. So 2 to the negative 1 plus 1, and then another plus 1. So that leaves us with negative 1 plus 1 is 0. So 2 to the 0 plus 1. And then we have to go back to our rule about anything with a 0 power. Anything with a 0 power is 1. So this right here, 2 to the 0 equals 1. So this is 1 plus 1 equals 2. So then our ordered pair is negative 1, 2. -1, 2. So there's 1 point for our graph. Let's keep going. We're going to go up. So 0, 2, parentheses, 0 plus 1 plus 1 over here. 0 plus 1 is 1. 2 to the first power plus 1. 2 to the first is just 2. Plus 1 equals 3. So 0, 3. 1, 2, 3. Let's keep going. Let's try 1. 2 to the 1 plus 1 plus 1. 2, or 1 plus 1 is 2, so 2 squared plus 1. 2 squared is 4, plus 1 is 5. So now we have 1, 5. 1, 1, 2, 3, 4, 5. I think this one's in the wrong spot. Yeah, let's erase it. Let's fix this. All right, 1, 2, 3. There we go. Let's see if we can get one more point that fits on our graph. 2, so 2 to the 2 plus 1 plus 1. 2 plus 1 is 3, so 2 to the third plus 1. 2 to the third is 2 times 2 times 2, so that's 8 plus 1 equals 9. So now we have 2, 9 for our ordered pair. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so there's our graph. We can connect these 3 dots. It's getting bigger and bigger pretty quickly. That's what it's called. That's why it's called an exponential graph. And then on this side, the line will never cross that yellow line that we drew. It'll get as close as we can to it, but it should not cross. All right, graph number 1. Let's try another one. -2 times 2 to the x minus 3 plus 4. All right, well, let's go through the same steps we had on the last question. Let's figure out what k is. K equals 4. So our line should never cross 4. 1, 2, 3, 4. Our line will never go across this line. It's either all going to be above or all be below this line. H is supposed to be up here, so it's supposed to be x minus h. It is x minus a number, so that means h equals 3. And we also know that a is negative, so our graph will only be below the line down here somewhere. So let's see what happens. We'll start with 3, and we'll see what happens. -2 times 2 to the 3 minus 3 plus 4. So -2. 3 minus 3 is 0, so this is 2 to the 0 plus 4. So 2 to the 0 is 1. So now this is -2 times 1 plus 4. -2 times 1 is -2 plus 4 is 2. So we have 3, 2, 1, 2, 3, 1, 2. All right, let's find another one. 4. -2 times 2 to the 4 minus 3 plus 4 equals 4 minus 3 is 1. -2 times 2 to the first power plus 4. 2 to the first is 2. -2 times 2 is -4. Plus 4 equals 0. So 4, 0. 1, 2, 3, 4. Oh, I put this one in the wrong spot too. Let's fix that. It should be 3, 2. 1, 2, 3, 1, 2. There we go. That feels better. All right. 5. Negative 2 times 2 to the 5 minus 3 plus 4. So let's see. 5 minus 3 is 2. So now we have negative 2 times 2. 5 minus 3 is 2 plus 4. All right. 2 squared is 4. 4 times negative 2 is negative 8 plus 4 equals negative 4. All right, 5, negative 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. All right, we kind of know where it's going. We need to get a little bit closer to our line, though, our line of our horizontal asymptote. We need to get a little closer to that. So let's go backwards. So we know 3, 4, 5. If we put in 6, we're just going to get a bigger number down here at the bottom. Let's see if we can get a little closer to our line. Let's put in 2. See what happens with 2. Negative 2 times 2 to the 2 minus 3 plus 4. Negative 2 times 2. 2 minus 3 is negative 1 plus 4. All right, this is the first time we've seen a negative exponent. We got to know what to do with a negative exponent. Let's highlight it real quick. Right here. Oh, let's go backwards. Let's change colors. Right here, this is a number with a negative exponent. So what do we do with a number with a negative exponent? What we're going to do is we're going to flip it over and make it positive. So this is really 2 over 1, right? It has a negative exponent, so that means we flip it over and make the exponent positive. So now instead of 2 over 1, we have 1 over 2. And then this negative 1 becomes a positive 1 plus 4. So that we're going to use on the next problem also, but right here, this negative exponent the negative exponent becomes positive if we flip it over. Right here. We're going to use this again on the next problem that we do in class, right here. All right, well, so now that we've changed it to a positive exponent, we can work it out. Negative 2 times 1/2 is negative 1 plus 4. Negative 1 plus 4 is 3. 2, 3 then is our ordered pair. 2, 1, 2, 3. There we go. Now we're a little closer to our line, so now we can draw our graph. We know it's going to go through all of these points and get bigger and bigger to the negative side, so closer and closer to infinity. And then on this side, it's going to get closer and closer to, but never cross the line. Hopefully I can draw it right. There we go. All right, the fraction problem we will talk about in class. So you can end your notes here. We'll see you in class. Be ready to go, be ready to ask questions, and be ready to do the third problem on your notes.